Hi everyone, my name is Jean-François Naud and I'm the Deputy Director of the Doping Control Lab of Montreal. Today during this poster presentation, I will talk about the recent results that were obtained by Philippe Desharnais during the development of a new method for the detection of activin receptor 2 fusion protein using capillary-electrophoresis. This is part of a larger project that was recently funded by the Partnership for Clean Competition. So, activin type 2 receptor recombinant uh, fusion proteins are created by adding the extracellular domain of activin receptor 2 to the Fc domain of an IgG1 antibody. And in this poster, we will use capillary electrophoresis Western blotting assay to detect these molecules. This method is more or less similar to the normal polyacrylamide gel electrophoresis followed by a Western blot, except that all these steps from the separation to the detection will be performed inside the capillary. Here on the right-hand side, you can see the small instrument where we can have 25 different capillaries per run, which means that we can have 25 samples, including the controls per run. So why studying these molecules? ActRII fusion proteins can, for example, stimulate erythropoiesis. This is the case for ACE536 and ACE11. These molecules can bind, for example, GDF11, and this will relieve the inhibition of the maturation into erythrocytes. This is then done in an EPO-independent manner. So the first experiment that we did was to determine if we could first detect these proteins, so these fusion proteins, and if so, what was the sensitivity of the capillary electrophoresis method. So there's two different ways to show these results. So there's this virtual blot, which is more like what we are used to see by Western blotting. And these, you can also show um, electropherogram like this one, which is more like something that we would have using normal chromatographic method. Here, what we can see is that using the pure standard, we can detect for sure as low as 1.56 picogram. And to be able to detect a peak, what is our criteria is that we need to have a signal to noise ratio that is close to 10. Let's say 9.7. If we then it's around 10, we will consider this signal to be strong enough. Then after, we wanted to repeat this assay, but in serum to determine the sensitivity and selectivity again. Here you see three different assays. So on the left-hand side, you can see an immunoprecipitation done for the activin receptor 2A class of molecules. In the middle, the 2B. And on the right-hand side, you can see that we mixed all the antibodies for the immunoprecipitation, but then the detection was performed here only for the activin receptor 2A class of molecules. For the two other assays, so the detection was for the same molecule as for the IP. This was just to show that we can probably multiplex all these antibodies for immunoprecipitation and then detect the molecules that we want. Uh, so the results here are showing that we can detect in serum at least an amount of 0.2 nanogram per ml. This is true for the activin receptor 2A and 2B. And those are really preliminary results. So the next step was to try to see if we could use an alternative method of blood collection. So we wanted to see if we can use DBS or dry blood spot to collect samples and to detect these molecules. It is important here to say that these molecules normally they are used in a large amount, so the sensitivity is quite enough to detect it easily. So what we did is that we used Tasso M20, in which we spiked some, or we put some blood that was spiked with the activin receptor 2 fusion proteins. We let it dry, and then we extract the molecules, and then we analyze on the capillary electrophoresis. So here what we can see is that for both activin receptor 2A and 2B class of molecules, we can detect easily 3.12 nanogram per ml. So this is shown here and here. And here, as a conclusion, I just show you a small table where you can have different values. So what we can see is that for the activin receptor 2 reference standard and 2A and 2B, we have a similar LOD. In serum, we have a less, or we have a better, let's say, detection in serum for the 2B, and the same for the DBS. However, those are really preliminary results, and we will need to test different antibodies to see if we can get lower or if we can have similar results for both class of molecules. And these LOQs here are just really something that we just put as an indication, but the complete validation needs to be done. So on this, I hope that you enjoy this presentation, and if you have questions, I will be pleased to answer. Thanks.